Hey guys, welcome to Coding with NJ. In this tutorial, we are going to learn all about creating and using our own API keys, both for authorizing access to our precious resources as well as a rate limiter to our resources. Rate limiting, also known as metering, is done for different reasons, such as when you want to charge different customers different rates based on their consumption of your resources. It is also helpful when it comes to risk mitigation, traffic shaping, security, etc. Now let's discuss why use API keys. In short, the API keys are used to uniquely identify the user or consumer of the API so that it can be charged per usage basis or identified as a culprit in case of some security breach. In my earlier tutorial, I have used IP address of the client to uniquely identify it, but IP address based identification has its limitations, such as one IP address might be representing 1000 employees of an organization, or if the user is behind a proxy, then we might never get the actual IP address of the user. In short, API key identifies a user with a fine-tooth comb. Okay, that's enough explanation, I think. Now let's peek at what we are going to develop in this tutorial. This is the landing page of our project, and over here, as you can see, there is no styling applied. We have just two buttons on our page. First one is for registering with the website or domain whose data you want to access. The second button is for actually accessing the data. So if you haven't yet registered with the website and you try to access the data, you will get the message that you need an API key to access our resource. So let's go and register. Let me put something. Submit. Now I have got a success message with this API key. Now we need to send this API key along with the request to get the data. Therefore, we need to store this API key somewhere. So I have stored this API key in the session storage. Let's go to the developers tool so that we can see if there is any such key. Let's go to applications, and this is the session storage. So this is the URL of our domain, which is localhost and then port 5500. And this port contains two keys. The first key is put in by the live server. It has nothing to do with our project, but this key that I have stored with the name API key belongs to this particular project. To store data in the session storage, every browser provides an object named session storage. Now we have API key stored in the session storage. Now we can request the data, and this time we will receive the data. So let's go and click over here. As you can see, I've got the list of all the actors, which is a table in the database whose data we are accessing. If we don't provide API key or we provide an invalid API key, we won't be able to receive the data. So let's go back and change the API key. Okay, let's put one more digit and let's try to access it. So it says invalid API key provided. Only when you provide the correct API key, which you got assigned when you registered with the website whose data we are accessing, only then you can get your data. Okay, so let's remove this 6 and request the data again. Okay. Now when we request the data for the first time, we are given a 30 seconds time slot. Within that 30 seconds, we can only request this data for just 10 times. So let me click it second time, third time, fourth, fifth, sixth, seventh, 8th, 9th, 10th. Now let's click it 11th time. We got you have exceeded your limit. So that means within those 30 seconds, we have already requested this data 10 times. We are not allowed to request this data until those 30 seconds expire. Once those 30 seconds expire, we will be able to make another request to get this data. Again, a new 30-second clock will start, and we can only make 10 requests within those 30 seconds. So this is the idea behind rate limiting, that we are limiting how many times each individual user can access a certain resource. So this is the demo, and now let's go and create this project. Let's create a front-end folder for all the files related to the front end. Now let's create index.html. I have generated boilerplate code. Let's change the title. Now in the body, if you remember, we had a heading and 2 buttons. Besides those 2 buttons, we are going to create 2 divs as well. One div is going to be used for registration related stuff, and another div is going to be used for displaying the data that we receive from the backend. And not backend, but from a different domain. Since I'm going to implement both front end and backend as 2 different and autonomous entities. So our front end is going to be a complete website in its own right, and our backend is going to be a complete website in its own right. And to do that, I'm going to run both of them on different ports. So if the ports are different, that means front end is a different website and backend is a different website. This is going to create an impression of one website requesting resources from another website through its API. So let's create heading first, and I'm going to have same heading that I have used for title. Now let's create 2 buttons. For the first one, I'm going to give it a class name Jane-button. We are going to use this button for registration purpose, and the second button is going to be for getting the data from the other website. Let's give it a class name useButton. Its caption is going to be get data. Next, we need a div through which we can register with the other website. So let's call it Jane API. Let's call it API key. Because when we register, we are going to get an API which we are going to use for getting data. And within this div, we need a form for registration. Let's give it class name registration-form. We don't need action attribute because we are going to send this request through fetch API. Within this form, we only require one input field of type email. The main reason for using one input field for registration is that since aim of this tutorial is looking how a API key is generated and how it is used, so I want to focus on that part. So just one input field is enough to register. So let's give it a name email as well and ID email as well. And let's create a label. Next, we need a button which is going to simulate the submission of the form, because we will define an event listener. So when this button is clicked, a fetch request gets sent to the other website. So let's give it a class name submit as well. Okay, so we are done with the first div. Now let's move on to the second div. And this div is going to be used once we have got our API key, and using this API key we want to request the other website to give us data. So the data is going to be displayed in this div, but it's going to be displayed dynamically through JavaScript once we have got the data from the other website. Therefore, we are going to keep this div empty. But let's, for the time being, put some random text. Eventually, I'm going to remove this text, but the reason for putting this text over here at the moment is that we have to define click events for both of those 2 buttons that we have defined at the top. So when we click on the register button, only the div which contains the form should get displayed, and this div, use API key div, that should be hidden. And when we click on get data button, we want this second div to appear and the first div with the form should disappear. And so in order to be certain that this logic is working properly, we need to have some text in this second div so that we can see is it appearing and disappearing based on which button has been clicked. So once we have defined this logic, I will remove this text from here as well. Now since we are going to use JavaScript, so that means we have to link the JavaScript file with this index.html file as well. So let's link it. And let's call it script.js. Let's create this file. Let's start our JavaScript file by defining the 2 event listeners that we just discussed for the register button and get data button. For that, we need references to both of those 2 buttons as well as the 2 divs. The class name that we have given to the registration button is Jane-button. And the class name for the second button was use-btn. Now let's create references for both of those divs. The class name to the first div that contains form is gen API key, and the class name for the second div is use API key. Now initially when index.html page is displayed, we want none of those divs to be visible. Therefore we have to set both of those divs display property to none. So gen div dot style dot display is none. Likewise use div dot style dot display is also set to none. Now let's define event listeners. So when one div appears, we have to make sure the other div must disappear. Gen div dot add event listener, click event. Let's define arrow function as its callback function, and within this arrow function let's copy these two lines. So when the button which says register is clicked, the style property, the display property of gen div should get changed to block. The other one must be set to none in case previously it has been reset to block. So it's not supposed to be div, it's supposed to be button. So when the register button is clicked, the gen div style property should be set to block and use div's style property should be set to none. Now let's copy this one because we need similar logic for the other button as well. So let's change this to use button from gen button, and let's set gen div back to none and use div set it to block. Now let's go and verify if the logic so far is working or not. So let me open the live server. So somehow we have set the display property of the button to none. Okay, so over here I'm supposed to say btn, not div. So gen button, use button, then gen div and use div. Okay, let's go and check again. Okay, now it's working properly. Register, we got email. Get data, we got lorem ipsum. Register and get data. Okay, perfect. Now even though we are not using any styling, it will still look much better if these contents are displayed in the center. So let's go to index.html, and for the body let's define inline styling, text align to center. So everything in the body should be in the center. Let's verify. Okay, that's better. Now let's work on the logic for this submit button so that when it gets clicked, a post request should go to another website whose data we want to access. Therefore, we must get registered with that website and get our API key in return. Since we have to work on the submit button and the email input field, therefore we must have references to those two HTML elements. So let's create those references. We haven't given any class name to the input field, but we did define an ID for that input field, which was email as well. So now we have references. Now let's define the event listener for the submit button. Click and the callback function. Let's pass it the event object. Since this submit button is inside the form, So whenever we click on this submit button, the default behavior of the form is that the form will try to send data to the server or to the destination which is defined in its action attribute. So even though there is no action attribute associated with this form, but it will still try to send a request. So that's the default behavior of the form. We have to disable this behavior. So we are going to say prevent default. So this is going to stop the form from sending a request somewhere or anywhere. The reason for that is that we are going to make this request through Fetch API. And in the Fetch API, the first parameter is going to be the URL of the website with which we want to communicate. So in our case, it's going to be HTTP localhost port 8080. And over there we are expecting a file named server.php. The second parameter to this fetch request is going to be an object. Since we intend to send the URL which is in the form along with this request, so therefore we must use a method post because we are sending some data in the body. The second attribute of this object is going to be mode attribute, and we have to set it to CORS, CORS, cross-origin resource sharing. We must set this property because we are going to develop our front end and back end as two separate websites. So one independent website is going to communicate with another website. So they are not going to be part of one website with a front end and back end. Each part is going to be a website in its own right. So two independent websites are going to communicate. So that means the resource sharing is going to be between two different websites. The default behavior for such kind of communication is disabled. We need to set different attributes for two different websites to pass data or share resources with each other. So one of them is that we have to set the mode in the fetch request to CORS. Now we have to send the data in the body. Now here's the thing. Since we are sending this request as a Fetch API request and not directly as a result of form being submitted, therefore the form's data will not be available in the PHP's global variable named $_post. But we want this data to be made available to that global variable. Therefore, we have to create a new object of type form data and pass our HTML form element as a reference to the form data's constructor. This way, this Fetch API will be able to make available all the data in the input fields in the $_post global variable. So we have to create an object of type form data, and we have to pass the reference of the form to this constructor. So let's go and check the class name that we have given to the form. It's rage-form. So document.querySelector rage form. Now we are good to send this request to the other website. So when we get the result from the other website, we expect it to be in the JSON format. So first then block is going to call JSON method on our response object and again return us another promise, therefore another then block, and this then block is going to actually contain the real data, the actual payload or the data that has been returned from the server, which in this case is going to be a completely independent website. So let's call it data. So for the time being, we are simply going to display whatever has been sent from the other website in the console. We will come back and redefine this part later on once we have defined the logic for the other website so that we really know what kind of data is being sent and how to display it properly. Okay. Let's define the catch block as well. In case something goes wrong, we should be able to see the error message as well. Okay, now let's go and define the counterpart for this so that we can be certain that at least the registration part is working properly. And at the end of the registration, we do get an API key. So Let's create a folder named backend, and within this folder let's create a file named server.php, because this is what we are going to call over here. Before we define any logic for server.php file, let's create another file for database connectivity first. So let's call it db.php, and over here we need to make a connection with the database and store it in a variable named connection new mysqli. Now this mysqli takes 4 parameters. The first one is going to be the IP address where our database is running. So in our case it's localhost. I prefer to put the port number as well, but if it's a default port which is 3306, then you can ignore the port. Second parameter is the username for the database, and the third parameter is the password. The username is root and password is also set to root. The fourth parameter is actual database with which we want to communicate. So I'm going to use a database named Sakila. This is a built-in database that comes with MySQL 8. So I haven't defined anything over here. It already has certain tables and data in those tables. So that's why I'm using one of those tables so that I don't have to create or enter any data. However, I have created another table named user in this database where I'm going to register the user that we are going to create through registration. So let me show you that database first. So this is the database and it comes with all these tables. This user table is the only table that I have created myself. As you can see, it has only 2 fields, an email and the API key. So email is the data that we receive from the user, and when the user is registered, an API key is generated and stored over here, and this API key uniquely identifies each user. As you can see, we have same email addresses but different API keys. So if we get a request to get data with this API key, that means this is the person who is making the request. And if we get this API key in the request, that means this is the person who is making this request. So even though emails are same, we are still able to uniquely identify each of them as individual users. So let me remove all of this data. Okay, now our table is empty, user table is empty. Now let's go back and work on the PHP logic. Now we want to make sure if we have actually successfully been able to connect with this database or not. So if the connection has not been made, in that case we want to end this script right there. Therefore we have to check if we have got connect error number. In that case, let's send JSON object with an associative array with the key named status, and its value is going to be connectivity failed, and then attach the exact error. Okay, we forgot to put semicolon over here. Next thing, we want to terminate the script, but only if we do get a connection error. Otherwise, this if part is not going to be executed and we will have an open connection with the database. Now we need to include this file in the server.php file. Okay, let's use require for including the db's script in this file. Let's use in the current folder we have a file named db.php. Now since we are going to treat our backend and front end as 2 separate domains or 2 separate websites, we have to set certain headers over here. Otherwise we will get the course error, cross-origin resource sharing. So we have to let this PHP know that it is okay to accept or send data to some other entity. We have to set at least 3 headers over here. but I'm going to define just one header for the time being, and I will keep on adding those headers when the need arises so that you know their significance as well. So for the time being, just like in the fetch request, we added an attribute named mode with its value set to quotes. We have to set a specific header over here, which is going to let this PHP know that which other websites are safe websites from where you can accept requests and send responses back. So that header is called access control allow origin. Through this header, we are basically telling PHP that what kind of outside URLs or outside websites are safe websites from where you can accept requests and send them responses back. So if we want to let this PHP accept requests from no matter where or which website that request comes from without any discrimination, we have to set this to asterisk. For the time being, this header is going to work. But later on, when we define the logic for the use data button, this will not work. And at that time, we will again set this asterisk to some other value. But since it's okay for the time being, so we are putting this asterisk over here. When this needs to be changed, then I'll change it to the other value so that you know when is it acceptable to put asterisk over here and when it isn't. Remember, we still have two more headers to define, but let's not worry about them until the need arises. Okay, now let's define the logic so that this PHP file is able to accept that fetch request and responds it back as well. And since we know that that fetch request is actually a post request, so we are going to check if the request that we have received, is it a post request or not. So therefore, if $_server and its request method element, is it equal to post or not. So if the fetch request that the server has just received if it is of type post, then this is the logic that should be executed in these two curly brackets. Okay, if the request is post, that means we actually have a request for registration. And we know that this registration request comes with a form with one input field named email. And that input field is available in the $_post global variable. So we have to extract that email. I'm creating a local variable named email and get that email from the post global variable. Since we have received this data from the client, our user, therefore we should sanitize it before using it in any queries. Therefore what I'm going to do is that I'm passing this to a method named real escape string, which we can get from the connection object. So this is the very minimalistic sanitization I have used. I should also have checked if this post global variable does contain a field named email or not. But in order to just focus on the main aim of our tutorial, I'm not going to carry out those checks. Now, once we get an email, we need to generate its API key, store it in the user table along with this email, and we have to send the response back to the user which made this registration request so that the user gets the API key as well. Then the user has to provide that API key if the user actually wants to get the data from this website. An API key is just a long string with random characters. We can generate that random string in as complex way as we like, but what I am going to do is that I am going to use a method named password hash to generate that random key from the email address that we have been given. So API key is going to be password hash. The first parameter for this password hash is going to be the value whose hash we want to create. And the second is going to be the exact algorithm that we want to use for this hashing procedure. So the algorithm that I'm going to use is called password default. There are many algorithms defined in the PHP. We can choose any algorithm we like for this hashing procedure, but I'm going to go for the password default one. Now we have to insert these two pieces of information as a new row in the user table. So let's execute a query through connection object. And within those double quotations, we have to provide the actual query. So insert into user table. In those brackets, we have to provide the column names. Email and API underscore key were the column names for the two columns. Now let's provide the values. So another set of parentheses, and within those parentheses, we have to provide the values. And since the data type for both of these fields is varchar, so that means they are strings. So therefore, we have to enclose the values in the quotations. First one is going to be email, and the second one is API key. Semicolon, which is the part of the query, and then semicolon, which is the part of PHP termination symbol. Now, if this query is executed successfully, then we get a Boolean value that we are going to store in the result variable. So now we are going to check if the execution was successful. That means a new row got created in the user table. In that case, we have to inform the user that made this registration request, and we have to send it the API key as well. In the case of failure, we also have to inform the user. So that we are going to define over here in the else part. Let's work on the success part first. So in that case, let's send a message to the user back as a JSON encoded object. So the associative array that we want to encode as JSON object is going to consist in this case two elements. The first one is going to represent the status, and we have to set it to success. The second one is going to contain the API key, and we have to set it to the variable API key. If that is not the case, in that case, again we have to send a similar message back to the client, but obviously there isn't going to be any API key, and the status is going to be set to failure. And let's terminate the script over here. Now, since we have completely defined the registration logic for both of the websites, let's go and check if this part is working properly or not. Our front end is running through the live server. Let's start the backend server on which we want our backend or the other website to keep on listening. Now, if you notice over here, currently I am in the folder named API rate limiter. So if I start my PHP server like that, now as you can see, this server is listening on localhost port 8080, and this server is considering the main folder, the API rate limiter, as the root folder for this website. So that means from this folder we can actually access the front end as well if we attach /frontend to this URL. But we don't want that to happen, and in fact we want on the back end to be considered the root folder of this server. So let me stop this server and again use the command, but this time we have to use a switch -t, and we have to provide the folder that we want to be considered the root folder, which is backend. So now, even though the URL is still the same, but now the root folder is this backend. If a request is made to localhost :8080 /server.php, it is going to serve this server.php, and we won't be able to go to the front end folder from this URL. So our front end is running through live server and our back end is running through PHP's web server. This way, front end is a completely independent website and back end is a completely independent website in its own right. So it's like communication between two separate websites. So let's go to front end. Let's register something, xyz at xyz.com. Submit. Let's see the console. As you can see, we have successfully received an object which consists of two attributes. The first one is named status with value success, and the second one is named API key with the value as an API key. Now all we need to do is display this data in the browser rather than in the console, and we also need to store this API key somewhere. So let's go and work on that. So this is the part which is displaying the data received from the server or the other website in the console. So we need to change this logic over here. Let's comment this out first. Now since we know this data consists of two fields in case of success, the first one is status. If its value is success, that means the other attribute contains API key. So we are going to check if data.status equals success. In that case, the first thing that we need to do is display the contents in the browser. And we are going to use the first div, that is the registration div, to display the result there. So let's registration div.innerHTML. Let's use backtick because we are going to use a string interpolation. So let's first display the status. Then on the next line, let's display the API key. Okay, now next we need to save this API key locally somewhere so that for the next request, which is actually accessing the data from the other website, we need to provide this key. And for the local storage purpose, each browser provides us two built-in APIs. One is called local storage and other is called session storage. Both of these storages have same set of API, but if you use local storage, the data is going to last longer. That is, even when we have closed the browser, the data is going to stay there. But if we use session storage, the moment the session expires or we close the browser window, the data gets erased. So it's up to us whichever one we want to use. I'm going to go for session storage. You can replace it with local storage if you like. Consequently, if I close the browser and then I reopen the browser, I will have to make another request for registration to get the API key, and only then I will be able to access the data. But if you have used local storage, the key will already be there, so you don't need to provide the key and you can directly go for accessing the data. So let's store it in session storage by calling is set method. Now the set method takes two parameters. The first one is going to be the name of the key with which the session storage is going to store this particular data that we want to store. So I'm going to give it the same name, API key. Obviously I can change it as well if I like, but I'm going to keep it same. And for the actual value, that comes from data.API key. That's all we needed to do, and now let's go and verify if it works. Refresh. Registration div is not defined. Oh, it's gen div. Refresh. Session storage.set is not a function. That's because it's actually set item, not set. Now as you can see, we got the messages success and the actual API key. Now if we go and check the application and local storage, session storage. And as you can see, we have a key with the name API key and its value, which matches exactly this key. Okay, and with this we have completed the first part of our project, that is registering with the third party, getting an API key and storing it in our session storage. Next we need to define the logic for actually requesting the data by providing this API key. Based on this API key, the server or the other website is going to recognize us as a valid or authenticated user, and not only just authenticated user, in fact the authorized user to access this data. So let's go and work on the front end of this functionality. We have to define an event listener for the use button, this one, and the logic for accessing the data is going to be defined within that event listener. So use button now let's send a fetch request to the same file, and for its object, since this time we are not going to send any data in the body, so therefore we are going to use getHTTP method. And since getHTTP method is default HTTP method for the fetch, therefore I'm not going to define this attribute at all over here. But since we are going to communicate with a separate entity, therefore we must define the mode, which is going to be course cross-origin resource sharing. And this time we actually have to send the API key along with this request. Therefore, we must set another variable called credentials and set its value to include. That means this request contains some credentials. Now we are able to send the API key in the header sections. So headers. We are not going to use any built-in headers because all those built-in headers have their own defined purpose. That means we have to define our own custom header. And a custom header is usually referred with the capital hex -API -key. So this is the name we are giving to our custom header, and let's add value to the API key that we have in our session storage. So we need to extract that API key from the session storage. Therefore session storage dot get item, and we have to provide the name of the key with which we have saved this API key. So the name that we gave was API key as well. So that's it. We don't have anything else to send along with this request. Therefore, we have to define the then part when we receive the reply back from the server or the other website. So it's going to be a JSON object. So let's call JSON method, which will return another promise, therefore another then clause. And here we have actual data. Again, for the time being, we are simply dumping the data in the console for the time being. Once we are able to see the different kinds of data or the responses that we receive from the server or the other website, then we will redefine the logic according to those messages. But for the time being, let's just dump it over here. Now let's define the catch block as well in case something goes wrong. Let me change this, remove this E. Okay, this is the front end logic for the time being. Now before we go and work on server.php file, I want you to pay attention to this attribute, which is credentials set to include. So whenever we have this credentials set to include, in that case, in the server.php file, this header, when it's set to asterisk, it won't work. So setting the access control allow origin to asterisk works as long as our request does not include any credentials, which can be user defined variables or cookies or session variables. So we need to replace this asterisk with the exact URL of the domain which is communicating with us. Therefore we have to set it to http localhost. So this is the domain part. We only have to provide the domain part, and currently it's running on port 5501. So we have to provide this port number as well, 5501. The next header that we need to define is set access control allow credentials set to true, because now we know that one of the requests contains credentials. We also need to inform this server.php file to accept a custom header named xAPI key. For that we have to set one of the headers named access control allow headers. and since name of the header is X API-key. Okay, now let's go and work on the actually accepting the request. Now since we know that the request is going to be a GET HTTP request, therefore let's copy this part. So if the request is of type GET, then this is the part that should start executing. Now let's first extract that API key which is in one of the headers. So I'm going to store it in a variable named user provided key, because this time the key is provided by the user. So all the headers are in a global variable named server, and within those square brackets we have to provide the header name. But since this is a custom header, we have to append HTTP to it first, then X API key, all capital. Now since it is possible that the user makes the request to access the data without actually providing the API key, therefore we must make sure that actually this key exists. So in order to check if the key exists or not, let's go back to the front end part first, and if you can see, the key is extracted from the session storage over here. So if there is no such key in our session storage currently, null value is going to be returned, and this null, when it's received through the server global variable, it gets transformed into a string. So null null becomes a string null. So therefore we have to check if user provided key contains a string null. In that case, actually there was no key provided from the client, otherwise the key was actually present. So we are going to check if user provided key equals string null. Now we have to send an appropriate response back to the client and terminate the program right here, because nobody is allowed to access this resource without an API key. So let's say echo, and since our client is expecting a JSON object, so let's convert it into JSON object. Let's set an element named status to no access allowed without API key. Now exit the program. Next we have to define if we have actually received an API key. So the logic onward is going to be, we have to check our cache if this API key is already in the cache or not. And since we are using Redis for the caching, I need to download a package named Redis so that our PHP can communicate with the Redis client. So let me open up another terminal window. And since this Redis package is related to our backend only, so first let me cd to the backend folder. Now I'm going to download the package Redis with the composer. If you haven't watched my other tutorials about Redis installation on Windows, please go and check out the tutorial. Now we have a package installed in the backend. As you can see, these three new entities have been downloaded, a vendor folder and two composer files. Let me go back to the first terminal. Now let's go up and include the autoload file. So in the current folder, we have a folder named vendor autoload.php. Now let's go down and create an instance of Redis client. Now we have got an instance of Redis client as well. Before we define any more code, let me give you an overview of what we are going to do. First, we will be searching in the Redis database for this particular API key. If a key is present in the Redis key, so that means that particular user has already made some request. This is not the first time the user is making this request. So we will check how many times it has already made the request. If the new request is within the amount of allowed request, we will get the data from actor table and send that data to the client. If that is not the case, That means no key is present in the Redis database. First of all, we have to verify if any user in our database exists with that API key. That means we have to search the user table. If we find any matching API key there, then we will store that API key in the Redis cache, set its counter to 1, and again go to the actor table, grab its data and send it back to the client. We will also set an expiry date of 30 seconds for that key to exist. So let's go and check if any such key exists in the Redis database. So we are going to use Redis client object and we want to check if a particular key exists. Therefore, we have to use the get method, and as a parameter to this get method, we have to provide the key that we are looking for. So the key is in our user provided key variable. So if this key exists in the Redis cache, then this cached variable is going to contain its value. Otherwise, this cached key is going to be null. So now we have to check if this key exists. In that case, the logic is defined in those curly brackets. So if the key exists in the Redis cache, following should happen, else the else part should execute. If no key exists in Redis, okay. When the API key already exists in the Redis cache, now we have to get its actual value, that how many times this key has been used to access the actor table. So we will store that value in the variable named hit count, and once more we will use Redis client and we will use the method named incur with user provided key. So what this is going to do, it's going to look for this key. If it's already there, it will increment that key's value and return that value, which will be stored in the hit count. If no such key is present, then this incur variable actually creates a value and set its value to 1 as well. But since we already know that a key does exist, that's why we are in the if part. So it will simply increment the value and return the value in the hit count variable. Now we have to check if the hit count is within the allowed threshold, that is the 10 requests per 30 seconds. So if hit count is less than or equal to 10, that means we can access the actor table. So the logic for accessing the actor table is going to be defined in another function, which we will call access actor, and we have to pass our connection variable to it. If hit count is greater than 10, that means the user has already used 10 requests per 30 seconds. So in that case, we have to send another response to the client, which is going to be, let's copy and paste it over here. We simply have to change the response. You have exceeded your limit. So if there is a key in the Redis cache, in that case, check its value. If it's less than or equal to 10, that means the user can access the actor table. Otherwise, user has already used 10 requests allowed per 30 seconds. So this is the logic for if the key is in the Redis cache. In the else part, we have to define the logic if the key does not exist in the Redis cache. So if the key does not exist in the Redis cache, that implies this is the very first time that user has made the request. Therefore, we have to verify if the key provided is it a valid key or not. So first of all, we have to go and talk to user table and check if any such key exists in the user table. So we have to use the connection variable and call query method, and the query that we are passing is, let's say, select everything from user table where API underscore key equals, replace single quotations with double quotations, because if we are using double quotations, then we can use string interpolation within the text as well. So the API key is going to come from variable user provided key. But since the data type of API key is string, that means we have to put it in single quotations. Now this semicolon represents the end of SQL statement. Okay. Now when this query executes, it's going to return us a result, so we are going to store it in a variable result. And this query can return number of rows based on how many rows were matched to this key. So we can check if result num rows, if we have some value in num rows, which is one of the methods in the result object returned from the query, then we are certain that at least we have found one row matching this API key, and this is enough for us to verify if the key is valid or not. Now because this is going to be the very first request from the client, therefore we have to store this key in the Redis cache as well. So for that we are going to use Redis client variable, and this time we are going to use incur method, because this incur method is going to set the value to 1 by default. All we need to do is we have to provide the key, which is in the Redis provided key variable. Okay, now we have a key with this API key stored in the Redis cache and its value set to 1. Now we need to attach an expiry date to it, so that represents the time slots of 30 seconds. So again, Redis client expire method, and the first one is going to be the key, the first parameter, and the second one is going to be the number of seconds. So we are going to set it to 30 seconds. Now we have stored the key in the Redis client and set an expiry time to 30 seconds. Now we have to actually access the actor table and return the result of that actor table to the client. I have forgotten to put semicolon over here, that's why. Okay, now we have to use the same method, access actor. Okay, so this is going to access the actor table and send the data from that table to the user. Now this part is going to be executed if we actually did find at least one row with the matching API key. We also need to take in account if no row was returned. In that case, the user provided incorrect valid key. So we have to define else part. In that case, again we have to send this message. Obviously the contents of the message are going to be different. Incorrect API key is provided. Let's say access denied. This is pretty much all the logic. All we need to do is that we have to define this function, access actor. So function access actor, and it receives connection object, which represents the connection to the database. In this function, we are going to connect with the actor database, grab its data and send it back to the client. We already have connection variable. We have to execute query, and the query is going to be select first name and last name from actor semicolon. And since this is going to return as result, a collection of rows, so we are storing it in a variable result. Ideally, we should check whether the result contains data or not, then we should proceed further, but I'm skipping this part. Let's create an array. We will be returning this array to the client, but after accumulating all the rows as an associative arrays into this array from the query. So let's iterate through the result variable while so this fetch assoc is going to take one row at a time from the result variable and convert it into associative array and stores it in the row variable. Then we are going to push this row to the array. So the first parameter is going to be the array name, and the second one is going to be the contents that we want to be pushed. Once the array has been populated with data, now it's time to send the reply back to the client. So echo JSON underscore encode the array and exit. Now our backend logic is complete. Let's go and check in the browser if we are able to get the data or not. Since we already have an API key in our session storage, so we should be able to make the request by clicking on this get data button. Since we haven't displayed any data in the div itself, let's go and check the console. Failed to execute fetch on window, failed to read credential property from request. That's because the exact value is not includes, it's include. Credentials is plural, but include is supposed to be singular. So let's go to the script and let's remove this S. Let's give it another try. So it says access control allow origin header has a value localhost 5501 that is not equal to the supplied origin. So the supplied origin, it says, is this one, and we have set it to, so we have to provide the exact match which is received by the server, which is 127.0.0.1, not the word localhost. So let's go and change it. Let's go up and let's set it to 127.0.0.1. Get data, some server error. Undefined array key, HTTP hex API key on line 24. It's actually underscore, not hyphen. Now we can make a request to get the data. Let's go and check the console because we have dumped everything there. It says JSON is not defined on line 50. Okay, over here. So it's supposed to be response.json, not just JSON. Okay. Okay, now let's give it another go. Get data. We didn't receive any data. It's because we have again used a different name. It's supposed to be ARRAY, not AARAY. Okay, now let's give it another go. Get data. Now you can see we have already got data, first name and last name. Now all we need to do is display this data in the browser rather than in the console. So let's go and work on that. So this is where we are dumping everything. Now if you remember the second part, it either returns an object with status attribute or it's going to return an array of objects, and each object consists of first name and last name. So this is the only data that is returned which doesn't have an attribute named status. Everything else has an attribute status. So we have two different types of data that we are sending from the server side website. So therefore over here let's comment this console log and we have to check the data, what kind of data we have received. If the data contains status attribute, that means we haven't received the data, rather some kind of error have been received. So if that is the case, we have to proceed in one way. Else, in the else part, we know that we have received the data and the data contains an array of objects. So we will be iterating through those objects and displaying them one at a time. But first, let's go and work on when we haven't received the data. Since in any case we will be displaying this data in the div, which was the second div, so we have to first of all clear its previous contents. Then we have to set use div dot inner HTML equals data dot status. Otherwise we know that we have received an array of objects. So let's iterate through those objects. Data dot for each, and within the body of this arrow function we have to create an HTML element of type paragraph. Now we are going to set the contents of each object as paragraph contents. Then we will append that paragraph as a child to the div. So p dot inner HTML is, let's use backtick, e dot first name, some space, then e dot last name. Now let's append this p to use div. Okay, that's it. That's all the logic for displaying the data in the browser rather than in the console. So let's go and check it out. Get data. Nothing happens. It's actually in our HTML, all capital. HTML should be capital. Okay, let's give it one more try. Okay, now we have received the data. Now I have clicked it once, twice, 3 times, 4, 5, 6, 7, 8, 9, 10. Now next click should not display this result. Okay, it hasn't displayed the result, but where is the message that we have exceeded the limit? Okay, again it should be capital. Get data 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now we get the message you have exceeded your limit, and we will keep on receiving this message until 30 seconds have passed. After 30 seconds we will be able to see the data again because the next window has started. Okay, there we go. Now we need to check if we send wrong key, does it still send us the correct message? Let's put 999 over here and get data. Access denied, incorrect API keys provided. Let's clear this API key and let's give it another try. This time it says no access allowed without API key because we haven't provided any API key. So that means our logic is handling every scenario properly. So this is the end of today's tutorial. In this tutorial, we learned how to create API keys and how to use them for authentication as well as authorization and rate limiting. We also learned how to use session storage, custom headers, and what kind of properties and headers we need to set if you want to communicate between two different websites or domains. I hope you liked this tutorial. Please don't forget to subscribe, like, and share. Thank you so much.